Andesite volcanoes. Explosive, beautiful, deadly. Pyroclastic flows, silent superheated mixtures of blocks, ash and gases. In the daytime, they look like expanding, energetic masses of grey cauliflower as they rush down the mountainside as a dense current of convecting ash at speeds of 100 miles an hour and more. At night, we see that they are red-hot flows with temperatures reaching 600 degrees centigrade, incinerating everything in their path. The rockfalls that roll down the sides of the dome are also incandescent blocks of hot lava recently extruded from the depths of the earth. As they tumble along, they break into smaller and smaller pieces, releasing the pressurized gases trapped within them. This giant glowing block has rolled down to within just a few yards of the camera. But what processes are taking place beneath these islands that cause these eruptions? And how was the Caribbean island chain formed? If we could look below the island of Montserrat, we would find that it is actually the tip of a 6,000-foot undersea volcano that has built up from the seafloor at the site of the collision of two gigantic plates of the Earth's crust. As the heavier Atlantic plate subducts beneath the Caribbean plate, the intense heat and pressure melts the plates into magma. This molten mixture can then rise, forcing itself into one or more chambers and, during an eruptive phase, may reach the surface. If it moves to the surface slowly, it may build a dome in the crater. But if it rises to the surface too quickly, the instant expansion of the highly pressurized gases may break the bubbly magma apart and lead to a violent and explosive eruption. There are different types of volcanoes found around the world. Most people are familiar with the basalt type of eruption. The lava is very fluid and can erupt in spectacular fountains, as we see here in the images from Kilauea volcano in Hawaii. Once this glowing material reaches the surface, it flows down the valleys, usually following the lowest parts of the topography. Another example of a basaltic volcano is Mount Etna, a stratovolcano rising over 3,000 meters above the east coast of Sicily. Although it is known as a basaltic type of volcano, it has been known to generate pyroclastic flows on occasion. Etna is one of the most active volcanoes in the world and has been erupting over many thousands of years. Montserrat Sophia Hills volcano, like all of the volcanoes in the Caribbean chain, is an andesite and explosive volcano. The andesite magma is much thicker and viscous. It comes up like very thick toothpaste, forming spines and blocks that pile up, eventually forming large dome-like structures. In Montserrat, these mountains of hot rock could build up to millions of cubic meters before collapsing and cascading down the sides of the dome. But let's go back to the summer of 1995. The island had just recovered from the most powerful storm to ever impact the Eastern Caribbean, Hurricane Hugo. It struck in 1989, lashing the entire island for hour after hour with sustained winds of 165 miles per hour, damaging 95% of the buildings and infrastructure. Now, after 5 years of rebuilding, the island was prospering as never before. As the sun rose on the morning of July 18, 1995, the colorful capital city of Plymouth was buzzing with activity. The loom at the Sea Island Cotton Company was shuttling back and forth in a steady rhythm, and the golfers at the Pelham Valley Golf Course were enjoying the cool morning breezes. Shortly after noon, a rumor began to spread over the island that steam vents had opened up in the crater of the South Sophia Hills volcano that overlooked the city. A drive to the east side of the island near Long Ground not only revealed the plumes of pressurized steam, but also massive flows of thick grey mud issuing from somewhere in the crater complex. Before long, scientists from the Seismic Research Unit in Trinidad, the British Geological Survey, and the United States Geological Survey were on island, and with the aid of a helicopter from a British Guard ship patrolling nearby, they were able to take a first-hand look. These unusual images show the early phreatic eruptions that developed over the next few weeks. This led to clouds of cold ash being carried by the trade winds over the city. By August of 1995, the first of 3 cycles of evacuations began. Let's listen in to the actual ZJB radio announcements as we take a look at Plymouth in those uncertain days.
Governor Frank Savage and Chief Minister Ruben Meade said they had been advised by the scientists on the island that the situation has escalated. This followed a major ash fall which covered Plymouth and the immediate surroundings areas just after 8 o'clock this morning.
As a result of a meeting which took place at 3 o'clock, the scientists have told us that they can no longer guarantee 6 hours notice, which we had previously been told was a reasonable expectation. Our contingency plan was predicated upon that. But we now have to review the situation in light of the new report from the scientists. The scientists are of a consensus that there is now more than a 50% chance of an eruption of some type from the volcano. This has taken the law of probability considerably up the scale. Based upon advice from the scientists, we are this evening proposing to evacuate all areas south of a line from below Richmond Hill, which would take in all of Plymouth. It would take in the central corridor that runs across the island to the villages in the east, up as far as the airport.
Over the next 2 years, the MVO continued to monitor every aspect of the eruption, measuring seismic activity, gas output, ground deformation, dome growth, and the environmental impact that the volcano was having on the island and its ecosystem. They also held village meetings to try to educate and inform the public and to do their best to answer the many questions on everyone's minds. The MVO chopper was on the go continuously, supporting and backing up the scientists, who at times worked right on the flanks of the mountain. Access to a helicopter allowed for close aerial observations of the crater. Here, we can see the growing dome still contained within the walls of the crater rim. The dome continued to grow and collapse through 1996 and 97, with the center of activity switching from one sector of the crater to another. The rate of growth would vary, sometimes reaching 7 to 10 cubic meters per second. This is about the amount of material carried in a small dump truck. As the dome grew taller, it also became more and more unstable. This would lead to bigger and bigger collapses and pyroclastic flows. These flows finally reached the sea on the east side of the island on Mother's Day, May 12 of 1996. These images were the first ever recorded of this incredible phenomenon. Almost 2/3 of the island had now been declared off limits. Checkpoints had been set up, manned by the police department and the Montserrat Defense Force, who were doing their best to prevent people from going back into the danger zone. Because of the evacuations, hundreds of people who had been forced to leave their homes and most of their belongings in the south of the island were now living in temporary shelters in churches, schools, and other buildings in the north. These are very difficult days, and the overcrowding, lack of facilities, little or no privacy, and almost constant ash falls was making life miserable for everyone. Many residents decided that they would just have to leave the island, not so much out of fear of the volcano, but because they no longer had a job, a place to live, or a school to send their children to. By June of 1997, a new feeling of concern was growing among the scientists that we could be entering a new and even more dangerous phase of activity. A remarkable cyclic pattern had been recognized in all of the monitoring signs, and by June 25, the cyclic patterns had reached their peak. The seismic machines at the observatory were scratching out almost constant signals, and then, just before 1 in the afternoon, all hell broke loose on the mountain.
It's big, guys.
Amanda, there is a large TF coming down Mosquito Gut in your direction, so once the siren is sounded, you scientists may withdraw once the siren is sounded, please. Over.
It's bigger than I've ever seen it.
Really?
Yeah.
Blow, wind, blow.
It's all the way going down toward the airport, believe it or not.
Yeah, it looks like it.
50 people up there.
Okay, as far as we know, nothing went down to the west, over. As far as we know, okay, over. Some of Bramble Village, certainly most of Bethel, most of Spanish Point, most of Farm, and most of all of Trans, or most of Trans has gone. And about the lower half of Heritage, there are many buildings on fire. Roger, Paul. Thanks for that. I'll relay that to Angus if he hasn't copied it over.
The June 25th eruption claimed 19 lives, but many residents whose means of escape had been cut off by the flows were rescued by helicopter. Then, in August of 1997, pyroclastic flows blasted over Gage's Wall on the western rim of the crater, surging into Plymouth and setting dozens of buildings aflame in the main business district. A walk into the main crossroads in the center of town, referred to by old-timers as Grand Stand, showed the force of the flows and the damage they had caused just a few nights before. These aerials, taken at the beginning of the eruption, show the beauty of the town before the August conflagration. Compare these images with these taken after that fateful night. You can see the crossroads of Grandstand passing below and the overall destruction that superheated pyroclastic flows and surges can cause. On through September, October, and November of 1997, the volcano continued to erupt with almost 80 explosions taking place at intervals of 6 to 10 hours. These spectacular images were captured during this amazingly predictable phase. One of these events took place September 21, generating a massive pyroclastic flow that swept down the mountain to the northeast of the volcano, surging right through the terminal of the recently closed Bramble Airport, reducing it to a burnt-out skeleton. Then, on Boxing Day, December 26 of 1997, the collapse of the southwest wall of the crater caused a tremendous lateral blast. As you can see in these before and after shots, the villages of St. Patrick's, Jingos, and Morris were literally swept out into the sea, leaving only a flat, grey, barren landscape where a thriving community once stood. Even after this massive collapse, the dome continued to grow until March of 1998, when it suddenly stopped. For the next 19 months, the volcano appeared to be relatively quiet on the outside, but all the monitoring signs indicated that the magma chamber was still active. Volcanic gases continued to be discharged, and there were occasional small explosive events and collapses as the old 1998 dome disintegrated. The staff of the MVO were continually watching all the incoming data, and they observed from the GPS measurements that the volcano was slowly inflating. Then, in November of 1999, after a lull of almost 2 years, a swarm of earthquakes heralded the resumption of dome growth. A second major phase of the eruption had begun. Dome growth continued over the next 4 years, with the dome reaching a significantly greater size than any of the domes that had grown in the 1995 to 1999 period. This ongoing growth caused further collapses that produced pyroclastic flows down the valleys, some reaching the sea by way of the Tar River Valley. When the weather was clear, you were able to see rockfalls and pyroclastic flows from vantage points on the east and west sides of the volcano. At night, the views were even more spectacular, with almost constant flows of hot rocks and gases cascading down the sides of the dome. This prolonged activity meant that scientists will be carefully monitoring the volcano for the foreseeable future. Thus, a new state-of-the-art volcano observatory was built and opened in December of 2002. By July of 2003, the dome was 1,100 meters above sea level and 190 meters above Chance's Peak, previously the highest point in Montserrat. With a volume of more than 200 million cubic meters, it was almost twice the size of the largest dome of 1998. In mid-July, the scientists were noticing a lot of elevated seismicity. An early tropical system was moving through the islands, bringing very heavy rains, and on the evening of July 12, after 2 days of downpours, the weakened and oversteepened dome finally collapsed down the valleys to the east and northeast of the volcano.